Hello everybody! In this video we are going to build a truncated icosahedron, or as we all know it, soccer ball, using plasticity. Let's get started. A few important pre-calculated numbers that we are going to use during these constructions are on the screen right now. These are mid-sphere radius, in-sphere radius for pentagons and hexagons, as they are already pre-calculated, and we are not going to go into the deep math of how all this is done. I am using millimeters, and we'll keep the grid size about 1000 with lines every 10 millimeter. So the soccer ball consists of hexagons and pentagons. Let's start by constructing our first hexagon. By holding shift and scrolling the mouse wheel, we can change the number of edges. So in our case, we need 6. It's going to be hexagon. The diameter of circumference I will set to 100, because in case of hexagon, the radius of the circumference around the hexagon equals the size, the edge of the hexagon. Next is going to be a pentagon. We don't need to be very precise. We'll ask Plasticity to help us to set the dimensions we need. So first I'm going to grab it in the freestyle. We'll take this edge. Now we'll just rotate in the freestyle as well around this point, holding this edge and making sure they are together. So now we need to scale the pentagon to make sure its size matches the edge length matches the edge of the hexagon. So very simple scale. In freestyle again, we're saying that we're going to scaling from this point, and we want to scale the edge. So holding this, and we move the edge up to the point we want to scale it. Now we need to also make sure that we scale uniformly, so all edges are scaled as we just did. Now I'm going to rotate both of these polygons, so it is a little bit easier to continue constructions. So rotate the freestyle, so rotate around the center of the hexagon, and I just want this edge to be on the x-axis. And the fun part starts. Let's create the first construction line. This is going to be the mid-sphere radius. The mid-sphere radius 2.47 assumes that the edge equal 1. In this case, we have the edge equal to 50. So this construction line is going to start from the middle of the edge. Make sure that there is still 90-degree angle here. One more time, 2.427 multiplied 5, 0. The in-sphere radius for pentagons, starting from the center of the pentagon, making sure 90-degree angle, and use 2.327. We multiply it by 5, 0 one more time, always the size of edge. Now the same for hexagon. From the center of the hexagon, 90-degree angle, 2.267 multiplied by 50, and we have our first construction lines. So what are these construction lines? These are the radiuses, and all of them, as you might have already figured out, they all meet at the center of the sphere. So what do? Go to the front view, select pentagon and the radius we constructed from it, rotate in the freestyle around the edge, take this point and bring it to the center of the sphere. The same for hexagon, rotate, freestyle, center of the sphere. Okay, so here we have the first elements of our soccer ball, and for the sake of simplicity I am going to position pentagon on the X panel, rotate, freestyle around this edge, and move it all in the freestyle again to the center. Okay, so now the z-axis is exactly in the middle of the pentagon. We can continue from here and basically copy all these polygons around to form the shape of the soccer ball, but instead I'm going to create solids out of them first, and after that we'll position all these solids. We don't need this construction line and this one as well. I'll create some additional construction polygons right now to form the solid. So the idea is basically just to make sure that we are connecting all the edges of hexagon with the center of the sphere. Now let's patch these new elements to start forming the solid. Shift J. And I'm going to delete these polylines as I patch them. And the last one. Okay. So this is the first element. I'm going to join all these sheets into a single solid. Here we go. I will temporarily hide the solid, and so we basically need to do exactly the same as we just did for hexagon. We need to build a solid from this pentagon. J to patch. Now let's do the same. Just need to patch. All these polylines as we don't need them anymore. Select all the new sheets and join them together into a solid. So now we have two first parts of the soccer ball. So as we don't really need the soccer ball to be completely solid inside and we just want to build the surface of it, I'm going to use the sphere to cut the parts from the solid that we don't need anymore. And we don't really need to be precise here. It can be literally just something like that. Yeah, I just want to make sure the sphere doesn't go outside of the polygons. Yeah, that should be perfectly fine. So now let's use the Boolean tool to cut the parts we don't need. Basically vice versa. Yeah, select The sphere is the cutting tool, and I'm going to keep it. So I'm going to do the same for another part, for another solid. Okay, so here we have two surfaces we want to use to form the soccer ball. Selecting both faces, Shift D to duplicate. Now we can delete both of the old solids, and we have surface. So these two parts of the surfaces, I don't really want them to use as sheets. I'm going to make them solids. We'll apply some bevel, and we will start positioning them around to form the soccer ball. So in order to make them solids, I'm going to use the thicken tool, and probably just 3 millimeters should be more than enough. By the way, we cannot use here extrusion, just to show you why, because if we do extrusion, it will kind of extrude to a wrong direction. It basically calculates the direction based on the geometry of the face, so this is not what we need. So we just need to add some thickness here. Again, 3 millimeters should be fine. So now, as we have two new solids that will form the shape of a soccer ball, we can delete these sheets. And I think I'm going to add bevel right away. Selecting faces, Control 2, so we automatically select all the edges of this face. B, bevel tool, and yeah, let's add some fillet here. Let's show edges, make sure. Yeah, it should be fine. Okay. So these are the first parts of our soccer ball. The next step is pretty easy. You can just select the body of this hexagon and use radial array to duplicate it 5 times around the z-axis. Here we go. So the next part is a little bit tricky. So we need to take this solid of this pentagon and position it 5 times on top of this hexagons. A little bit tricky because we need to construct the temporary construction plane, so we rotate this pentagon precisely around specific area. First, I'm going to duplicate and rotate this pentagon around the z-axis. This is very important. So using the pivot point, we'll say that I am rotating it around the origin. Okay, and I'll specify exactly 180 degrees. The reason why I am rotating this is because I want this corner to go all the way up here. And so when I rotate this pentagon around the center of the sphere of the soccer ball, it will go exactly to this location. So as I said, in order to do so, we need to build a construction plane. And this construction plane is going to be exactly following this edge. So if you can imagine this, so this corner rotates around the center of the sphere, goes all the way here. To do that, I'm going to bring back this construction line. You remember that the end of this line represents the center of the sphere, center of the soccer ball. So I'm going to construct the temporary construction plane, which is going to be the surface for rotation. Let's select the face of the temporary construction plane we just created and hit space. Now we say that temporary construction plane is here. If I hit this button, we have the custom plane available for us, so we can always get back to it. Now let's select the solid that we duplicated. It is this one, and by going back to temporary construction plane, we'll say that we want to rotate this solid in freestyle, and we want to rotate it around exactly the end of the, basically the center of the sphere. And we want to take this corner and match it to exact this location. Now you can see, with the help of this temporary construction plane, we brought the pentagon to this exact location. So we can delete the temporary construction plane by selecting it and hit enter. I will also delete the polyline we used for construction, as we don't need it anymore. Again, the next step is pretty simple. Just select this solid and use the radial ray to rotate, duplicate it around the z-axis. The next step, again, going to be a little bit tricky. We will also need to construct the temporary construction plane, as we need to position these hexagons here to positions over here. Yeah, so basically we need to take this hexagon, and take this edge, rotate it around the center of the sphere, and position it at this location. So now the question is that how do we construct the construction plane we need? Well, the answer is relatively simple. We can use this edge one more time. So if you can think about it, this edge here, and this corner is exact at the center of the edge of the hexagon. So if we rotate this hexagon around the center of the sphere, so that edge is going to be here. Let's do that, bringing back the initial construction line that represents the center of the sphere, using polylines to build construction plane. Okay. Now we need a copy of one of the hexagons. So it's going to be this one in our case, Shift D. And obviously we don't need to rotate it at all. So now let's select the polyline, the face of this polyline, space to get into temporary construction plane, hit button to save, so we can always refer to it. Select the solid that we just duplicated, and double click on the temporary construction plane, rotate in the freestyle, and say we want to rotate it again around the center of the sphere. And what we want to rotate, we want to take this mid edge and bring it back exactly here. Hit OK, and delete the temporary construction plane, as we don't need it anymore, and also delete the polyline that we don't need it as well. And the next step is very simple. Select the body of the hexagon and yes, use radial array to copy it 5 times around the z-axis. And here we go, we have it. So now as you can see, this is exact half of the soccer ball. And we can just select all these bodies, mirror them, okay, and just position them at the location we need. So now we need to rotate this new part to the right position, and to do this we basically just need to rotate around the z-axis by 180 divided by 5. Now all we need is to move to the right position, and I'm going to use freestyle one more time, the right location, and what I really want is to take this upper part, and in the freestyle mode I'm going to say select this point and position it exactly at this corresponding point. And here we go. We have a soccer ball. Now if you want to go a little bit further, you can just do, let's select all pentagons. I think I have selected them all. Control G to group. We'll say 5, and everything else is obviously going to be another group. Control G, and we'll call it 6. Now by selecting the group we can say, let's first enable the material view. Right now it doesn't really show us anything. Let's right click here and say click on show edges so they're not shown. By clicking on the edge group and hitting M button, we can assign the material. So for pentagons it's going to be black, and I will also say roughness, a little bit rough, so it's not that shiny. And for our hexagons I'll do the same, hit M. The color is already white, so I will just add a bit of roughness here so it is not that shiny. And here we go. Congratulations. Now you have the soccer ball. Oh, and I just noticed that one of the pentagons looks like is in the group of hexagons, but it's easy to fix. Just take the solid, bring it to another group, and because all the solids inherit material from the group, we have the color assigned right away. Thank you. If you have any questions, feel free to leave them in the comments.